All right. Here we are.
More fun with trig and the unit circle, our favorite part of math and something you have to know. Woo! Okay, we're now going to consider our angle. You know how you learned SOHCAHTOA? You've learned that before, and probably learned that in geometry. You used it here. Well, we are now going to change those letters, the opposite over hypotenuse, to sine is y over r, cosine is x over r, and tangent is y over x. So let's look at our diagram over here. Notice that what we have is we have a pair of intersecting xy axes, and we have this radius coming out from the origin. That is always the hypotenuse. So our perpendicular side is always drawn to the x-axis, never the y-axis, okay? And so since we have this little embedded triangle that you see here, notice that our x-axis side is x. That's our adjacent to the angle side. Our side of our triangle that's opposite our angle is y, and that hypotenuse is always going to be r. Okay? So now when we look at this angle theta and we look at opposite over hypotenuse, we now have to think about it as y over r. Okay? So this is a very important transition to make. All right, example 1. We are going to find the sine, cosine, and tangent of the angle that passes through 2, -1. Now the first thing we have to do is figure out where 2, -1 is. So
I know that. I was in math when I was in middle school.
Now from our origin, yes you were, from our origin we are going to draw a radius that goes through that point. Okay, and now what we want you to see is the angle that we want is this angle here. That is our angle theta. Okay? I don't like calling it theta. It was theta. All right, too bad. Get rid of it. Get used to it. Okay, but now what this gives us is a triangle, a right triangle in this orientation. Looks like this. We have an angle, and there's our right angle. Our horizontal side is 2, and our vertical side is -1. Now, how do you think we would find r? Well, you know x squared plus y squared is r squared, so, or Pythagorean theorem, or circle centered at the origin like we talked about the other day. So we are looking at 2 squared plus -1 squared equals r squared. So 4 plus 1 is r squared. So what does that make r? Square root of 5. By the way, how come we don't do plus minus?
Because you can't have negative distance.
We cannot have a negative distance. We can talk about negative radii when we get to polar coordinates, but right now we are only talking distance, and so it's going to always be positive. Now, if we look at our ratio, the new ratio we have to learn, our sine is y over r. Let's look over here. Our x equals 2 and our y equals -1. Okay, yeah, x equals 2 and y is -1. So we have that the sine of theta, always for now while you're learning it, write it out, y over r. And now we have that the sine of theta is -1 over square root of 5. You can leave it like that, but you should be able to quickly change that to negative square root of 5 over 5. And what about the cosine of theta? Our cosine is now x. So cosine of theta is x over r, so we are looking at that as 2 over the square root of 5, which also is 2 square roots of 5 over 5. And the last one is the tangent of theta. Our tangent of theta is y over x, so that is -1/2. Now, before we move on, let's look at something really important. We have quadrants here, right? What quadrant are we in? We are in 4. And in quadrant 4, we have x positive, y negative. So notice that our ratio involving sine is going to be negative. Our ratio involving cosine, because we're in quadrant 4 and x is positive, is going to be positive. And our ratio for tangent, which is y over x, notice those are opposite signs, should be negative. Very important to pay attention to that from the beginning.
All right, so go to section 6.4 and work number 4. No calculators.
Okay. So once again, here you see those wonderful ratios, and we are now going to talk about what happens when that point lies on the unit circle. Now remember, the unit circle is where the square root, the radius is 1. Okay, and so notice that if we take the sine of an angle, t, I'm using t this time instead of theta, it's all the same. It's y over r, which is y over 1, so look at that, sine of theta is y on the unit circle. Cosine of theta is x on the unit circle. So the really important thing to know from this is that our point xy becomes the point cosine theta, that's for x, comma, sine theta. Now that's really important because in a little bit we're going to develop the unit circle and we're going to put coordinates on it.
Yep.
And if you learn the coordinates, then you know the sine and cosine of the angle, and the tangent's going to be super easy because tangent's going to be the y over the x. So that's going to actually be the sine over the cosine.
Okay, so now we have new unit descriptions. So here we've got the tangent is y over x, the cotangent is x over y, the secant is 1 over x, and the cosecant is 1 over y.
And the important thing to learn from that is that tangent can be represented as sine over cosine, and cotangent can be represented as cosine over sine. And so we call these in trigonometry our quotient identities. Do I have to know that? Yeah, you do. Those are quotient identities. Why? Because the tangent and cotangent are represented as a quotient of two other functions. These, secant, notice that that is r over x. 1 over x is r over x. Cosecant is r over y. Remember, we're on the unit circle, so r is 1. So these are our reciprocal identities.
And this one's r over x. Here we go. And that's r over y.
Yeah, again, you have to know those, know them, love them. When you come to class next time, every single formula you're getting today has to be memorized. Not just something you can look at on your sheet, you have to know it. All right? Okay. So now we talk about domain and range. There's a lot of words on this screen, but let's talk about the key thing. When you take the sine and the cosine, let's remember those are y over r and x over r. There is no restriction for substituting anything in because we're on a circle, so the radius is never 0. So since the radius is never 0, you have no restriction for anything you can substitute in. But what is interesting is that the range will always be numbers between -1 and 1, and that is because y and x can never be bigger than r. There are going to be times when they're equal to r or the negative of r, and you'll see that in a little bit, but they can never be bigger than r. So the biggest those ratios will ever be is -1 to 1.
Or negative r to r.
Yeah, that's actually a good way to think about it.
Because the ratio, this is for the unit circle. So you have to think about it as what's the radius, and that's the biggest it can be.
Well, and actually
it's not even, well, yeah.
Yeah, even if it's not on the unit circle, the ratio will never be.
The ratio.
Yeah, the ratio will never be a bigger than 1 or smaller than -1. Now that's for sine and cosine. Tangent, different rules altogether. Tangent's defined as y over x. So if you look at this, there is a place we cannot substitute, and that is when x is 0. Where on the circle does x happen to be 0? At the points 0, 1 and 0, -1, and if you recall from the last lesson, that is going to be at pi over 2 or 90 degrees and 3 pi over 2 or 270. And I'm going to tell you right now, we're going to use everything in terms of radians, so please get used to that. Right, now our domain, it's kind of interesting for y over x. What's going to happen here is we actually have the domain is plus or minus pi over 2 plus 2 pi k. Huh? What does that mean? Well, if we just look at the circle here and we just look at these points here, okay? Okay, so we're at 0, 1, which is at pi over 2, and we're at 0, -1, which is at negative pi over 2. Notice that when we go to the first quadrant here, okay, all of those values in the first quadrant are going to get repeated in the second quadrant, but in the second quadrant they're going to be negative. All of those values in the first quadrant are going to get repeated again when we get to the third quadrant, and in the third quadrant we're going to have positive values because in quadrant 3 x and y are both negative, so the ratio would be positive. And in quadrant 4 those values get repeated again, but in this quadrant, once again, because the signs on x and y are different, our tangent's going to be negative. Notice that if we just take from negative pi over 2 to pi over 2. Every single value that happens for tangent occurs in that interval. And that is why the domain is from negative pi over 2 to pi over 2. And then we can add multiples. That plus 2 pi k really means multiples of 2 pi. That's 2 pi times some number. It's a revolution around the circle. That's kind of hard to understand right now, but trust me, you will understand this in the coming days.
There we go.
Okay, you'll get that a lot better. And the range is the set of all real numbers because we're going to go, you can have anything for a ratio when you're looking at y over x. Okay? All right, the next thing on your notes is some really important stuff you need to visualize, you need to understand, and you need to memorize. Notice that by this point we're expecting that you know that the sine is y over r, cosine is x over r, and tangent is y over x. Okay, we expect you to know that by this point of the notes. And so, quadrant 1, positive, positive, all three trig functions and their reciprocals will be positive. So we're just going to put a little a right here in the corner. We'll explain that in a minute. In quadrant 2, where you have x negative, any ratio that involves x is going to be negative. So we have cosine and tangent are going to be negative. In quadrant 3, we have both signs negative, so anything that involves sine or cosine by itself, or x or y by itself, will be negative. But the one ratio that involves both x and y is positive, so we'll put a t in that corner. And over here in quadrant 4, we have the x positive, the y negative. So anything that involves only y is going to be negative. Now, what in the world did all those numbers, those letters mean? This means all of the functions are positive. This means the sine function is positive. This means the tangent function and its reciprocals are positive. And this is cosine is positive. We have a stupid way to remember that. That is, all students take calculus. Yes. Or we could say amazing students take calculus. Anyway, that will help you remember which functions are positive in which quadrant. So now we want to go and look at special angles. Our quadrantal angles are the angles for which we have points on the quadrants. These are not in quadrants, they're on the quadrant boundaries, so we call them quadrantal angles. Remember that this is known as 0 and it is also 2 pi. You need to remember those are both. Okay, this is at pi over 2. Here's pi. Here's 3 pi over 2. And then we need to know the coordinates for these. At 0, our coordinate is 1, 0. At pi over 2, it's 0, 0, 1. At pi, it's negative 1, 0. And at 3 pi over 2, it's 0, negative 1. Now, if we're on the unit circle, what is our radius?
1.
So we now have, for these 4 angles, we have the x and the y, and we know the r. All right, so coming over here at 0, let's remember that this is actually on the point 1, 0. And so, yeah, I do that too sometimes. That's the point 1, 0. And we can come over here and write over here just to remind ourselves that the sine is y over r. Cosine is x over r. Tangent is y over x. And now let's reciprocate these. Cotangent x over y, secant r over x, and cosecant r over y. And once we have the points and we know our radius is 1, here we go. Our sine is 0 over 1, which of course you need to know without thinking is 0. Cosine is 1 over 1, which becomes 1. Tangent 0 over 1, which becomes 0. Cotangent 1 over 0, which is undefined. Secant is 1 over 1, which is 1. Cosecant 1 over 0, which is undefined. Now, the rest of this chart, we leave it to you to fill out right now. Stop the video and do it right now. And those of you in my class, you know how upset I got when the last chart was not completed. So let's be sure to complete it.
Okay, for an angle theta in standard position, the reference angle is the positive acute angle formed by the terminal side or theta in the x-axis. Okay? They're never made with the y-axis. We're talking about angles that are made with the x-axis. Okay?
Yeah, and we can refer to them as t or as theta. And it varies from book to books, but This book is going to use T prime, so T prime or theta prime. Whenever you see those symbols, we are talking about the reference angle. So let's look at this. This first one, notice that our terminal side is ending in quadrant 1. So because we have not rotated all the way around, we are just in quadrant 1. Our reference angle is actually the same angle we're looking at, but it gets more interesting when we go to quadrant 2.
The reason we need to know about reference angles is because we're going to draw triangles, and you can't at right triangles, and you can't draw a right triangle with an obtuse angle. That's not possible. So basically, if we're trying to draw a right triangle with the x-axis, you have to think, oh, well, this guy right here, if I drop my vertical there, that would be my right angle. So this is my reference angle. Okay?
Yeah, that we're going to refer to. Exactly. And so how do we find that? Well, let's just say that that's a 30-degree angle. Do you see that we have not quite gotten to 180, so 180 minus 150, that would give this to be a 30-degree angle. So that's how we find it. Okay?
So use your geometry knowledge. Like, for example, here, this is going to be my reference angle, this guy right here, because that's where I would drop my perpendicular to the x-axis to make my little triangle.
Do you ever make the triangle with the y-axis?
Oh, never, 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 never.
No,
Never,
make
never.
it with the x-axis only.
Okay, now let's look at this. We have 180 degrees because we know that a line is 180 degrees from 0 to 180, or pi, plus this little piece right here. So we're going to do this angle minus whatever this,
actually,
minus 180.
Yeah, there we
so
go.
t minus 180 is going to be our angle.
Yeah. And you can see visually, I think you can figure it out. You just have to look at what's happening as we move all the way around the circle. But it's really important. This is really, really important.
So here we have another one. Notice that this is almost 360. So we could do 360 minus this piece, and that would give us our reference angle.
Okay. All right, so to find our sine and cosine tangent of t radians, what we're going to do, always sketch the angle in standard position. What does standard position mean? It means that one side of your angle is on the positive x-axis. So sketch your angle and then figure out what quadrant you're in. The terminal side. Then you're going to find the reference angle, and then you're going to find sine, cosine, and tangent. And remember, it says using the appropriate sign. That is the appropriate positive, negative, depending on what quadrant you're in.
So this has a negative because he's going down, all right? Negative,
Yep.
Positive, negative. Right, you know that.
So here we go with, these are finding reference angles. So go ahead and do that, and you're just finding reference angles. All right, now, we are going to actually use the reference angles, and notice in each one of these we have drawn a coordinate axis for you to help you with your understanding. Now 5 pi over 4 is bigger than 4 pi over 4, which means we're past pi. And it turns out that we're going to be in this quadrant right here. And you should know that 5 pi over 4 puts you in this quadrant. And that is going to make us, our reference angle is this little guy right here. Okay, and that is, so we're going to write t prime is pi over 4. Now, if we just draw our little triangle, what we have here, this is going to be a 45, 45, 90 triangle. And what do we know about that? This side is 1, this side is 1, and this side is square root of 2. But actually, we are in quadrant 3, so we now are thinking coordinates. That would be -1, -1. And remember, radius is always positive. So what is our sine of 5 pi over 4? Our sine of 5 pi over 4.
Well, the problem we have here is that my radius is supposed to be 1.
Yeah, it is.
But, we're not really worried
Yeah,
about
we're not worried about that. We're not on the unit circle. We can still have an angle 5 pi over 4 and not be on the unit circle, but we are going to deal with that radius needs to be 1 in a little bit. So the sine of 5 pi over 4 is?
Well, the opposite, or the
y
is -1 over the radius, which is square root of 2.
And what would the cosine of 5 pi over 4 be?
-1 over square root of 2.
Now, oh, look at that. Those are the same. Notice when you have 45-degree reference angle, sine and cosine have the same ratio. They may not always have the same SIGN sign. Tangent is y over x, and notice you've got a -1 over -1, so that is 1. Okay? All right, so looking here at 5 pi over 3. Notice that 3 goes into 180, 60 the 180 divided by 3 is 60, so our reference angle is 60. So we have a 30, 60, 90 with a reference angle of 60 in quadrant 4. Okay, 5 pi over 3 is right here. Okay, and if we do our draw our 30, 60, 90 triangle, kind of in the orientation it would be in that quadrant, what we get is, now getting the triangle, we know that if this is our 60-degree angle, this side is square root of 3, this side is 1, this side is 2, and we're in quadrant 4.
I'm getting happy with the square roots.
And we're in quadrant 4, so the y-coordinate is negative in quadrant 4. And now you're ready to do sine of 5 pi over 3, which is negative square root of 3 over 2. Cosine 5 pi over 3, this is your x over your r, x is 1 over 2. Tangent of 5 pi over 3, that's the y over the x. That is negative square root of 3 over 1, so we're going to just write that as negative square root of 3.
Okay, now the last one. All right, 5 pi over 6 is actually in this quadrant right here, and that's 1/6 pi left, so this is a reference angle of 30.
And again, you can find that quickly by thinking 180 divided by 6 is 30, so that's your reference angle. That gives you a quick way to get there.
Okay, because pi over 6. All right, so now that we have that, we're going to go ahead and draw our triangle. This is 30. That's a right triangle. And so this is
1.
1, 2, square root of 3.
And we're in quadrant 2, so something's negative.
Negative square root of 3. So sine is, what was it?
And by the way,
5 pi
notice
over
how we
6.
always write the angle sine of 5 pi over 6. You can't just say sine.
Sine of 5 pi over 6 is 1 over 2. Cosine of 5 pi over 6 is negative square root of 3 over 2. And the tangent of 5 pi over 6 is negative 1 over the square root of 3.
Which, again, you can recognize should go to negative square root of 3 over 3.
Which we didn't do over here, but yeah.
Yeah, and our t prime here was, by the way, pi over 3. Yeah. Okay, this is really important that you are able to do these ratios and look at these angles and see the triangle in your head. That is the important thing. Seeing that triangle is everything. Notice that you have to actually really know those ratios for your 30, 60, 90, and 45, 45, 90. If you have not memorized these ratios, you are dead in the water from this point forward. As far as all things trig go, you will not be able to do anything. So you must memorize those. If you have not memorized that yet, you need to do it today.
All right, do number 30 and number 34. No calcs.
Okay, sometimes we have an angle that is bigger than one revolution of the circle. One revolution, if you recall, is 2 pi. So sometimes you have an angle that's bigger than that, and we have to use still our reference angle to get to that angle. So what is 9 pi over 4? Well, if we go to our circle, it's going to do this.
Well, we've got 2 pi's, or 8 pi over 4. So 9 pi over 4 would be right here.
So again, we're going to sketch that radius that represents the terminal side of the circle, and we're going to write theta prime is pi over 4. Now, why is that important? Because that lets us think about that triangle and visualize it in our head, or draw it out if you have to. And we know that we've got the side 1, 1, and square root of 2. And now our theta is 9 pi over 4. So our theta prime is pi over 4. Remember that that is actually coterminal. Okay? Theta prime, pi over 4 is coterminal to 9 pi over 4. And now sine of 9 pi over 4 is going to actually equal the sine of pi over 4. That's an important relationship. And it's 1 over square root of 2. The cosine of 9 pi over 4 is also 1 over square root of 2. And the tangent is cool beans, 1 over 1, which is 1.
Okay.
Now, go ahead.
Go and do number 32 in section 6-4.
And now, I'll do it with you. I'm good. Okay. And now, the big chihuahua. Earlier in the lesson, we wanted to show you something that's really, really important. So we're going to go around and we're going to work with our angles in a minute, but we brought up something that, you know, if we look at our triangles, Ms. Miller is labeling them. Let's go simply to this one. And we know that that is 1, 1, and square root of 2. But on the unit circle, this radius needs to be 1. Now, how do we legally, in mathematical land, how do we get that square root of 2 to equal 1?
We subtract.
No, we divide by square root of 2, so we actually have to write this as square root of 2 over square root of 2, which makes that 1. And if we divide that by square root of 2, we divide everything by square root of 2. So this triangle, and you should remember this from geometry, this is similar to the one that is the side 1, 1 square root of 2, but this allows us to come over here at 45 degrees, and we can write that on the circle we are at pi over 4 here. That's the angle we're at. Okay, and our coordinates are 1 over square root of 2 and 1 over square root of 2. By the way, what's another way to write 1 over square root of 2?
Square root of 2 over 2.
And we're going to, for the purposes of making it easy, leave it like that. Now let's do something similar with this triangle here that you have. All right, we know that this is 1, square root of 3, and 2. But that hypotenuse,
the hypotenuse is 1, so we have to divide everything by 2.
And that makes that equal to 1. So when we come over here to pi over 6, we now can see that our x is the square root of 3 over 2. Remember, cosine is x. And our y is 1/2. Now, when we go to 30, 60, 90 down here, we've got the same relationships. Everything's just moved around a little bit. Our hypotenuse is still 2. But now our short side's on the x-axis, and our longer side is vertical. And again, we're going to divide everything by square root of 2. Okay. Reference angle of 60 puts us at pi over 3. And let's look at our x-coordinate. Our x-coordinate is 1/2, and our y-coordinate is square root of 3 over 2. Now, let's also do this. Let's go ahead and take a moment and go around the circle. And inside the circle, let's write the angles in degrees. Outside the circle, let's write the angle in radians. And then we're going to come in and put all the points. All right, so we're at 0, which is also 0 radians and 2 pi radians. And 0 degrees is also 360 degrees. Okay, 30 degrees. We've done that one. 45 degrees, 60 degrees up there. We're at 90 degrees, 120, 135, 150, 180, 210, 225, oopsie, 240, 270, 300, 315, 330, and once again we're back at 360. Now let's go and let's work our pi over 4s. Okay, so here's pi over 4. So if we come over here to quadrant 2.
This is pi over 2.
Oh yeah, we forgot that.
This is pi. This is 3 pi over 2. And this is 2 pi.
Let's come over here to,
So
what
this
would
is
that angle be?
3 pi over 4. That's pi.
Now,
5 pi over 4. And 6 pi over 4, 7 pi over 4.
Yeah. Now let's go here to this one and look at pi over 4, our blue triangle over here. Do you see the x and the y? The x and the y here are going to be the same except for x is negative. So in quadrant 2, we have the same coordinates, but x is negative 1 over square root of 2 and y is 1 over square root of 2. Let's go down to quadrant 3. At 5 pi over 4, we have the same x and y, but both are negative. So it's negative 1 over square root of 2, negative 1 over square root of 2. And quadrant 4, x is positive in this quadrant, 1 over square root of 2, and negative 1 over square root of 2. Okay. All right, let's look at our let's go 60 degree reference angle. We had that in green. 60 degrees. Okay. Here's our triangle for 60. Okay, look at our relationship. Our x is 1/2. See, the x is shorter, the shorter side. Square root of 3 over 2 is...
Okay, we've got 60 degrees. Pi over 3, this is 2 pi over 3. This is 3 pi over 3. 4 pi over 3. 5 pi over 3. 6 pi over 3 is that one.
All right, so again, these angles are going to have the same relationship as our x and y in quadrant 1. It's just that you have to put the correct sign on them. X is negative in quadrant 2, so it's negative 1/2, and square root of 3 over 2 for y. Down here in quadrant 3, both are negative, so we are talking negative 1/2 and negative square root of 3 over 2. And in quadrant 4, x is positive and y is negative. Okay, now here's the cool thing. If you look at your 60-degree reference angle, so at pi over 3, and you look at your 30-degree reference angle at pi over 6, notice the x's and the y's are the same, but they're switched. Why? That's because the vertical and horizontal sides of your triangle are also switched. So, here we go. Quadrant...
Well, first we need to put the
we need to
pies.
put the, yeah.
So we've got 1 pi over 6, 2 pi, 3 pi, 4 pi, 5 pi.
And a good way to actually get there is notice that this angle is actually just 1 pi over 6 short of getting to pi. So pi minus 1 pi over 6 is an easier way to think about that 5 pi over 6. And if we look at this one, 7 pi over 6, notice that that is one 30-degree angle past 180. And if you go down to quadrant 4, notice that 330 is 1 pi over 6 short of 2 pi. So 2 pi minus 1 pi over 6 is 11 pi over 6. So here we go. We're ready to put the values for our x and y. And in quadrant 2, x is negative. So negative square root of 3 over 2.
Negative. Oh.
And positive 1/2. Quadrant 3, both are negative. Quadrant 4, x is positive, y is negative. Now, how is this useful? First of all, this gives you a circle that you can always sketch out to learn to remember your values. Do you have to memorize all of this? Yes, but how do you memorize it best? You memorize it by knowing the first quadrant. Once you have the first quadrant values figured out with using your reference angle and visualizing the triangles, you can get all the other stuff relatively quickly. Also, why is this useful? Because if I want the sine of 4 pi over 3, sine, the y value is the sine. And the cosine, that O in there stands for the other value, that's the x. Okay, so the cosine of 4 pi over 3 is negative 1/2. So this is a really, really important thing for you to be able to know and do. So you have quite a bit to memorize and have ready to be recited at the next class.
Okay. Don't forget to bring your entrance ticket. This thing you learned, email us. Please put your class period on the email. Thank you.
Bye.